Hello, Mr. Taylor here. Taking a look at equations with variables on both sides. Let's be a little bit clear with what we're saying. Is we want to look at an equation that has variables on both sides of the equal sign. We're going to do this two ways. The first way we're going to take a look at is modeling using algebraic tiles. So what are we trying to learn? If we can represent and solve equation with the variables on both sides of the equal sign. Some key vocabulary words we want you to take a look at and understand is the word coefficient. And what a coefficient is simply a number that is multiplied by a variable in an algebraic expression. So if I had, let's say, 2y, well, my coefficient in this case is the number that's in front of the variable, because this is 2 times y, so of course 2 would be my coefficient. And then we want you to be aware of the constant term. And a constant is a term that doesn't change. So if I had 2y plus 6, well, 2 is my coefficient, so it couldn't be my constant because it is being multiplied by this particular y. But here we see that if we look at 6, 6 is all by itself. 6 won't change. There's nothing we can do to 6 to make it change. So that will be my constant term in this scenario. So let's get into modeling an equation with variables on both sides. And we want to use this algebraic tile model to take a look at this equation. I put a little key up at the top for you. And the key says if we see we have a small block with a plus on it, that means a positive 1. And if we have a small block with a negative on it, that's a negative 1. And what we're trying to do when we solve these is come up with these zero pairs. So if we take a positive and a negative and combine them, we're going to get 0. Then of course we see that the rectangular or the larger block with the x with the plus on it, we want to use that for the variable x. Okay, so let's go right ahead and take a look at this first model that we want to work. It says x plus 5 is equal to 3x minus 1. Now something that we have to keep in mind is as we go to bring these things over, whether we're going to take our constant term and go left with it or our constant term and go right with it, we have to make sure, and I'm not saying that it won't work either way, but you just really want to make sure that you take your smallest value, especially with your variable. So in this case, this is my left and right of the equation. This is my left and right of my algebraic tile model, and of course this straight line or this vertical line is my equal sign. So if I'm going to model this, I'm looking at, and what I was saying earlier is you want to make sure that you take the smallest variable and take it, add or subtract it to the largest variable, and that keeps from dealing with negative coefficients and coefficients, negative coefficients. There's a possibility that we can make some calculation errors with those. So you want to make sure that you understand that, and we'll talk about it as we keep going. Well, let's take a look at the model. This tells me that I have 1x and I have 1, 2, 3, 4, 5 1s. So this on the left side is saying that I have x plus 5. And there's my equal sign. And then over here I have 1, 2, 3 x's. And this says I have a negative 1. So now I can determine from here, well, if I'm modeling x 5 on the left side of the mat and 3x minus 1 on the right side, then I have to also remember that this 3x minus 1 is the same thing as 3x plus a negative 1. That's the rules of real numbers, or rules of integers, is what we've learned. So we must be cognizant of that. Okay. Let's take a look at the second part of what we're trying to do. Here it tells us that we need to move one x tile, remove one x tile from both sides. And again, we're trying to constitute that zero pair. So I'm starting here. I'm not starting from the right. I'm starting from the left side, because remember I said I wanted to take that smallest x to the side with the largest amount of x. So here I'm going to take this 1x and subtract it over here, and I'm going to subtract it over here as well. Okay, so as you notice, when I remove one of the x tiles from both sides, this is the same thing, as I said, as subtracting x from both sides of the equation. Okay, so now let's take a look at the next thing that we do. Now you notice here what this arrow is pointing down, if we subtracted that x away, so what's left over here? 1, 2, 3, 4, 5, 6. So the only thing we're left with over here is actually 6. Well, how did we get to 6? Well, we got to 6 because we had to add 1 to both sides to offset the negative 1 over here. So adding 1 to this side and adding 1 to this side makes this a zero pair. And now I have 6 that I have on the left side. So here, placing one number tile on both sides is the same thing as adding 1 to both sides of the equation. And again, I'm removing a zero pair. Okay, so what I'm left with here is 2 x's. They come straight down. So I have 2 x's, and the 6 1's come down. 2, 4, 6, 1. So if we separate these into 2 equal groups, which means here or here, I'm winding up with 1 x tile is equal to 3 plus 1 tiles. So if that's the case, my solution is telling me that x is equal to 3. Okay, so it's really straightforward dealing with those tiles, but just remember that in order to get the variable tiles alone on one side, you have to create a zero pair by doing whatever the inverse is of the equation. Okay, now here's what I need for you to do. If you don't mind, pause the video and take a look at how do you think you can check the solution to x plus 5 is equal to 3x minus 1 using the algebraic tiles. And then once you do so, pause and then think you figure it out, then come on back and let's go ahead and take a look at it. Alright, so let's see what you have. So in order, if we want to use the tiles to check it, what we want to do is we want to replace. So we want to replace each x tile with 3 plus 1 tiles. And if we do that, we have to make sure that we remove any zero pairs and see if the equation is balanced. So let's say make sure that we remove, sorry about that. far. Let's go back. So we want to remove any zero pair. Okay. Now, let's go a little further. We've taken a look at the actual tiles, but we know that we can make a step forward and look at these from an equation point of view, an algebraic point of view, should I say. So now let's solve equation with variables on both sides by using algebraic equations. So it says in the book that we can use this type of setup or type of equations or format to use to solve real world situations, and we can think of some right off the bat, like comparing phones or comparing price for soft drinks or whatever the case may be, to determine which one is going to give us the actual better deal. So, scenario. And this rental car charges an initial fee of $20 plus an additional $30 per day to rent a car. Buddy's rental car charges an initial fee of $36 plus an additional $28 per day. So, what number of days is the total charge by each company the same? Okay, so that means when will Andy equal Buddy? Or when will Buddy equal Andy? So let's take a look at what we need to do. First step. We want to write an expression representing what each one of the car rental places charge. So we'll start with Andy. It says A comes before B. Only reason. So we see that Andy charges $20. If we're thinking about the initial cost or the y-intercept, this is where that is. And then he also charges $30 per day. So for X amount of days, he's going to charge 30. So we can say, let's use X for days. So we're looking at total cost is equal to 20 plus 30X, or the expression is 20 plus 30X. So now what about Buddy? Buddy begins with a $36 fee. That $36 fee could be application fee, a check, your credit card, whatever the case may be. But in order for you to rent the car, you got to pay him a $36 fee, and he charges the $28 per day for the car. Okay? So we've come up with the two expressions. Now, let's see what we have to do now. So let's take these two expressions and write an equation that can be solved to find the number of days for which the total cost charged by the companies would be the same. So if that's the case, the total cost for Andy's must equal the total cost for Buddy's. Okay, that makes sense. So I'm looking at 20 plus 30X must equal to 36 plus 28X. Now, could we have changed this and said 30X plus 20 is equal to 28X plus 36? Yes, we could have. Yes, we could have. We could have easily made that distinction. So don't think that it is written in stone by one way. We can set these up in any particular manner. Now, let's solve for X. So remember what we said, or should I say, keep this part in mind. We can subtract 30 from this side, from the left side, and bring it to the right side. But we will wind up with a negative 2x. So we want you to think about always looking at the smallest x value of variable or coefficient, should I say, and taking it over to the larger one to eliminate the negative coefficient here. So this particular case, we're going to subtract 28 from the right and subtract 28 from the left. Now, what's going to happen when I do that? There's my zero pair right there. 28x minus 28x is 0. On the left side, I'll bring down my 20, and I'll have 30x minus 28x is going to give me 2x, and then on the right side, I'll bring down my 36. There's no need to put the 0 here. I mean, you could put it there, but that's not going to do you any good whatsoever, because 0 plus anything is simply 0. Okay, so now I'm left with 20 plus 2x is equal to 36, and what I need to do now is get my constant term. Remember we said that a term that does not have a variable is a constant term. So they are like terms. So we have 20 and 36, different side of the equal sign. So we need to take, we've already brought the x's to the left, so we got to bring the constants to the right. So subtracting 20, because that's the inverse of adding, will give me my 0 pair, and then I'm left with subtracting 20 on this side. So on the left side, I bring down my 2x, and here 36 minus 20 will give me 16. So if I look at this equation that says 2x is equal to 16, I look at my 2. So this is 2 times x. What is the inverse of times? It is division. So I will divide both sides by 2. So I'm going to put my 2 underneath my coefficient on the left and my 2 underneath my constant over here. So 2 divided into 2 is going to give me 1, bring down my x, and 2 divided into 16 is going to give me 8. So what I did was found out that since 8 is days, and that's what they're asking us to find, find the number of days, that the cost will be the same for the rental in 8 days. All right. Now, what I want you to do is, again, I want you to pause the video. As a matter of fact, let this serve as your notes that you want to bring to class for us to look at. So number 2 is I want you to work this and then bring it, and then if you have problems, then we'll work it out as we go. Water tank holds 256 gallons, but is leaking at a rate of 3 gallons per week. A second water tank holds 384 gallons, but is leaking at a rate of 5 gallons per week. So you need to determine what is your initial amount, and your amount of leakage. Okay? Again, you need to determine what's for the second water tank, your initial amount and your amount of leakage. So if we were to, pretty much set these up, what I see is 256 plus, would that be plus? Think about that. It is leaking. Right. So this will be minus 3x. The next one will be 384 minus 5x. And this equation can easily be set up as 256 minus 3x is equal to 384 minus 5x. We can subtract, or should we say add 3x, because that is subtracting. The inverse will be to add. If we do so, this is going to give us our 0 pair. So we'll just bring down our 256, and that's going to equal to bring down our 384, and that's going to equal to 8x. Okay. Well, will it be 8x? let's go back and look at this carefully. I do not want to make a critical mistake at this point. So if we're subtracting, we're adding 3x, so we're going to add 3x to this side as well. And if we're adding 3x, go ahead and get rid of this 8x here. If we're adding 3x, we'll have a negative 2x. Now, look carefully at what I just did. I just literally, and what I should have done was added the 5x to both sides. So what I wind up with, look, a negative coefficient. And that's what we said we were trying to avoid, the negative coefficient. But anyway, we're there. Let's go ahead and keep rolling. So that's 256 is equal to 3x minus 2x, 384 minus 2x. So let's go ahead and put it here. 256 is equal to 384 minus 2x, I think is what we have exactly. So here we have no other choice but to subtract 384 from both sides here. Now again, if I would have done this correctly, from what I just said the rules were, we wouldn't have gotten these negative numbers. So again, my zero pair, so I'm just going to bring down my negative 2x, and then I'm going to simply subtract 256 from 384. So 384 minus 256 is going to give me 128, but that's a negative 128 because that's bigger. Now I am going to divide by this coefficient in front of x, which happened to be a negative 2. Not just 2, there's a negative 2 there. So of course that's going to bring me down, bring my x down, and a negative into a negative gives me a positive 1. And now I'm looking at 2 goes into 12, 6, and in the 8, 4. Negative is a positive. So my x is equal to 64. So what this is telling me, if we're all good and right here, what this is telling me that after how many weeks will the amount of water in the two tanks be the same? And it will be after 64. All right.